Hi, welcome to IT and Automation. Last week and a week before came up with videos around pod disruption budget and topology constraints. And today we will deep dive into pod priorities in a limited amount of time without boring you. Let's zoom a bit into this pod priority now. So here we will today cover around scheduling decision and typically a pod priority, and we will deep dive in few details in here. We'll look into the key concepts of pod priority. We'll look into creating priority classes, how to assign that to the pods, scheduling behaviors. We'll look into the ordering, preemption. We will look into the high priority pods and low priority pods, how we can create that. We can look into the working examples as well. I'll share all of these details in the GitHub as always. Without delaying, let's jump into the topic. So what you should understand is using a pod priority and preemption in Kubernetes is like building a fence around your critical workload and ensuring they have the resources they need and are scheduled appropriately, especially in the resource constraints environment or typically around the multi-tenant clusters where a node can be swamped by different resources. So again, pod priority allows you to specify the importance of the different workload, ensuring that the most critical application are scheduled before the less critical ones. So talking about key concepts, priority class is a resource used to define priority level. You create a priority classes and then you assign them to the pod. So if the pod has a higher priority, they will say get scheduled first. And then if the resource are scarce, lower priority get lesser chance to get in comparatively to the higher priority. That's where the preemption comes, a process where the scheduler evicts lower priority pods to make a room for those higher priority pods. So if the cluster doesn't have enough resources, you kick out the lower priorities or the one without priorities and give maximum room to the higher priority pod. So next one here, creating priority classes. How do you create a priority class? You create this resource basically. This is the manifest for the resource, and each priority class has a value which defines the priority of the priority class, I should say. A priority class objects can have the value of any 32-bit integer smaller than or equals to 1 billion, which means the value can range from negative to 1 billion. Larger numbers are reserved for built-in priority classes such as system critical and node critical. So high priority, this is the high priority YAML, which is kind, as I mentioned before, priority class, metadata, you give a name that is suitable for you, value that, which is what we talked about, up to 1 billion. I'm saying this is not a global default. Low priority would be exactly similar with a lesser in number. I'm giving a gap in here in between these numbers so that if I need to feed a midterm priority for any reason, those can be placed as well. So here, kubectl apply -f. If I do high priority, that should create a resource there. kubectl get priority class high priority, that got created, right? And we could also do that to the low priority, and let's look into the resource that has been created. Yeah, that resource got created, right? So that means nothing yet, right? What we did is we created a priority class object with higher and lower. Now it will only come to an action when you attach that to the pod, right? So assigning priority classes to the pod is our next topic here. So here we have pod hi YAML. Very simple. It's a pod kind creating, and I'm giving a name of high priority pod there. It will use the priority class that we created a few seconds before, and we'll create a container with that name with the image nginx. So here, what is the assignment? Where does the assignment come from? Is priority class name. That's the assignment. So here we could say kubectl apply -f there. Right, the pod got created. So if we jump into the K9s and look into pods and then search for high priority, here we go. And this got created as that. And there must be a priority class called this, which pulls out the priority. And that's how you create pod attached with the priority. It would have been the same for low priority, pod low. If you apply that, that will create a low priority pod as well. So we looked into key concept, creating a priority class, assigning that. So from a scheduling behavior, let's pick scheduling order now, right? When there are pending pods and not enough resources, what scheduler does is scheduler will prioritize the pod with a higher priority class values, as we covered in a way or other before. Pods with higher priority values are scheduled before the lower values, basically. And from a preemption perspective, if the higher priority pod cannot be scheduled due to the resource constraints, scheduler will or may preempt or evict the lower priority pod to free up the resources. This is controlled by the preemption policy. So here, this is preemption policy, and preemption lower priority means it's a default, can be set to never as well if preemption is not desired. So if you don't want to evict the lower priority, you'd say never. Again, to recap, if a higher priority pod cannot be scheduled due to the lack of resource, the lower priority pods will be evicted. So next, let's look into handling pod priority and preemption. One of the thing I would say is avoid unnecessary preemption. So define priority classes carefully to avoid the frequent preemption. Otherwise, there will be lots of instability. Balance resources is another thing, like ensure a balanced resource allocation strategy to minimize the need of preemption. Preemption should be really where you have resource limitations and then you want higher priority to be there up before others, right? Use default priority optionally, right? Define a default priority class by setting a global default true and then assign that to lower pods and intentionally assign the higher priority to the higher pods, basically. And it's critical to monitor events, logs, to see the scheduling and preemption events. You got to be on top of these events. Otherwise, there may be surprises. Check scheduler logs for detailed information on scheduling decisions. Use Kubernetes metrics, likes of Prometheus, to observe resource uses and scheduling behaviors. And finally, pod priority, as I said before, pod priority is a Kubernetes. It's a powerful feature for managing resource, but can also backfire. So it has to be some of the things has to be considered, like unnecessary preemption, balanced resources. But again, as a powerful feature it is really good and essential for managing resources allocation and scheduling, and especially around the multi-tenant or resource constraints environment. By defining and assigning priority classes, you can ensure that critical application receives the resource they need, while the less critical applications are scheduled with a lower priority. And this comes with that preemption, right? the preemption, which does it for you. If you have that hierarchy of an application in a resource constrained environment, you get the benefit out of that preemption policies. So yeah, again, to recap, we looked into the pod priority, which is one of the key for scheduling decisions. Next week, we will come with another topic in scheduling decisions, one of the evaluation factors. Stay tuned. Thank you.